Hello my dear students, welcome to my physics class. Our today's topic is determination of equivalent resistance and current flowing through different resistances of the circuit. This was your homework. Here the circuit is given. Our first question is find the equivalent resistance of the above circuit, and second question, find the current flowing through each resistance. Today I will discuss about this circuit, how to determine the equivalent resistance of this circuit, and how to determine the current flowing through different resistances of this circuit. Let's start now. This is our given circuit. Consider this point is A and this point is B, this point is C. A point, B point and C point. And consider this resistance is R1 resistance and the value of R1 is 50 ohm. This resistance is R2 and R2 is equal to 75 ohm. This resistance is R3. R3 is equal to 25 ohm. This is R4. This resistance is R4 resistance and R4 is equal to 100 ohm. And this resistance is R5. R5 is equal to 125 ohm. And this resistance is R6. R6 is equal to 25 ohm. This is R1, R2, R3, R4, R5, R6. There are 6 resistances in this circuit, and some resistances are connected in series and some resistances are connected in parallel in this circuit. It is a mixed circuit. At first we will determine the equivalent resistance of this circuit. Equivalent resistance of R2 and R3 is RS1 is equal to R2 plus R3. Here R2 resistance and R3 resistance, these two resistances are connected in series, same path. We know here current is flowing through R2 and R3 is same. Here same current is flowing through R2 and R3 resistances. Therefore these two resistances are connected in series, so their equivalent resistance RS1 is equal to R2 plus R3, and this is equal to R2 is equal to 75 ohm and R3 is equal to 25. Here R3 is equal to 25 ohm. So 75 ohm plus 25 ohm is equal to 100 ohm. That is equivalent resistance of 75 ohm and 25 ohm is 100 ohm. Now equivalent resistance between A and B is, that is, now we determine the equivalent resistance between A point and B point. There are 3 resistances between A point and B point, R1, R2 and R3. And already we know R2 and R3 are connected in series. This R2 and R3, these two resistances are connected with R1 in parallel, because here current I current, that is main current, is split into two parts. One part is along R1 and another part is through R2 and R3. Therefore R1 resistance is connected in parallel with R2 and R3, and the equivalent resistance of R2 and R3 is 100 ohm and R1 is 50 ohm. So the equivalent resistance between A point and B point, 1 by Rp1. Rp1 is the equivalent resistance of Rs1 and R1. Therefore, 1 by Rs1 plus 1 by R1. These two resistances are connected in parallel with this resistance. Therefore, Rs 1 by Rs1. Rs1 is equal to 100 plus 1 by R1. 1 by R1 means 50. Therefore, this is equal to 101 plus 2. Here calculation, simple calculation. This is equal to 3 divided by 100. That is 1 by Rp1 is equal to 3 divided by 100. Therefore, Rp1 is equal to 100 divided by 3. And after calculation, Rp1 is equal to 33.33 ohm. This is the resistance, equivalent resistance between A point and B point. That is, equivalent resistance of these three resistances is 33.33 ohm. Now we will determine the equivalent resistance of R5 and R6. Equivalent resistance of R5 and R6 is Rs2. Here R5 and R6, these two resistances are connected in series. So the equivalent resistance of R5 and R6 is Rs2 is equal to R5 plus R6, and here R5 is equal to 125 ohm and R6 is equal to 25 ohm. Therefore, this is equal to 150 ohm. That is, the equivalent resistance of 125 ohm and 25 ohm is 150 ohm. Now we will determine the equivalent resistance between B point and C point. Now equivalent resistance between B and C is, that is, equivalent resistance between B point and C point is 1 by Rp2 is equal to 1 by Rs2. Here Rs2 is the equivalent resistance of R5 and R6, and these two resistances are connected in parallel with this R4 resistance, because here current is split into two parts. One part is along R5 and R6 and another part is through the R4 resistance, and these two current will meet at point C and again will produce I current. Therefore, 1 by Rp2 is equal to 1 by Rs2 plus 1 by R4. This is equal to 1 by Rs2 is equal to 150. 150 plus 100, 1 divided by 100. This is equal to 300. 2 plus 3. Simple calculation. This is equal to 5 divided by 300. And 1 by Rp2 is equal to 5 divided by 300. Therefore, Rp2 is equal to 300 divided by 5, and 300 divided by 5 is equal to 60 ohm. That is, equivalent resistance between B point and C point is 60 ohm. Equivalent resistance between A and B point is 33.33 ohm, and between B point and C point is 60 ohm. This 33.33 ohm and this 60 ohm, these two resistances are now connected in series. So we will determine the equivalent resistance of this circuit now. So equivalent resistance of the circuit is Rs is equal to Rp1. Rp1 means equivalent resistance of these three resistances, and Rp2 is the equivalent resistance of these three resistances, and here Rp1 and Rp2 is connected in series now. Therefore, Rs is equal to Rp1 plus Rp2, and we know Rp1 is equal to 33.33 ohm plus Rp2 is equal to 60 ohm. This is equal to 93.33 ohm. This is the equivalent resistance of all these 6 resistances, and this is our answer. Now we will determine the main current of this circuit, that is I current is flowing through this circuit. Already we have determined the equivalent resistance of this circuit, and equivalent resistance of this circuit is 93.33 ohm, and here voltage of the electric source is 220 volt, that is V is equal to 220 volt, and equivalent resistance is 93.33 ohm. So main current of the circuit is I is equal to V divided by RS. V is equal to 220 volt and RS is equal to 93.33. 93.33 is the equivalent resistance of all these resistances, and after calculation 2.357 ampere. This is the main current of this circuit. And now we will determine the current flowing through resistance R1, through resistance R2, R3, through resistance R4, and through resistance R5 and R6. And we know same current is flowing through R2 and R3 because R2 and R3 are connected in series. Therefore same current is flowing through these two resistances, and here also R5 and R6 are connected in series, so same current is flowing through R5 and R6 resistances. Now potential difference between A and B is here point A and point B. We know the equivalent resistance of these three resistances is 33.33 ohm, that is RP1, and main current is I. So potential difference between point A and B is VAB is equal to I into RP1. RP1 is the equivalent resistance of all these three resistances R1, R2 and R3. So VAB is equal to I into RP1. Here I is equal to 2.357 into 33.33. This is equal to 78.56 volt. That is potential difference between A and B point is 78.56 volt. Similarly, potential difference between B point and C point. Here between B point and C point equivalent resistance is 60 ohm and current flowing I, and I is equal to 2.357. That is potential difference between B point and C point is I into RP2. RP2 is the equivalent resistance of all these three resistances R4, R5 and R6. So I into RP2 is equal to 2.357 into 60. This is equal to 141.42 volt. That is potential difference between A and B point is 78.56 volt, and between B point and C point is 141.42 volt, and this 2 volt, that is 141.42 plus 78.56, this will be 220 volt. That is a part of 220 volt is dropped here, A and B, and remaining part 141.42 volt is dropped here. It is here 78.56 volt and here 141.42 volt. Now current flowing through the resistance R1 is, that is through resistance R1 current flow, consider this current flow is I1, and I1 is equal to, we know I is equal to V divided by R. V means potential difference across the resistance R1, that is potential difference between two ends of this resistance R1 is VAB, and we know VAB is equal to 78.56 and R1 is equal to 50. So 78.56 divided by 50 is the current flowing I1 through the resistance R1, and after calculation it is 1.57 ampere. That is, one part of I is flowing through R1 and this part is 1.57 ampere. Now we will determine the another part which is flowing through resistance R2 and R3. As the same current is flowing through resistance R2 and R3, we will determine it. Current flowing through resistance R2 and R3 is I2. Here I2 is flowing through R2 and R3. So I2 is the same current through R2 and R3. I2 is equal to, here potential difference between two ends of R2 and R3. R2 and R3 are connected in series, so their potential difference is VAB, A point and B point, and equivalent resistance 75 and 25. That is, equivalent resistance of these two resistances is RS1 and this one is 100 ohm. So 75.56 divided by 100, this is equal to 0.78 ampere. Now current flowing through the resistance R4. Here through resistance R4 is equal to 100 ohm, and potential difference between two ends of this resistance B and C, that is potential difference between B and C point is VBC. We know it, I3 is equal to VBC divided by R4, and VBC is equal to, already we have determined it, 141.42 divided by 100, and after calculation this is 1.414 ampere. This is the current flowing through the resistance R4. Now we will determine the current flowing through the resistance R5 and R6. Current flowing through resistance R5 and R6 is I4. This current, consider I4, VBC divided by RS2. Equivalent resistance of these two resistances is RS2, and potential difference between B point and C point is VBC, and this is equal to 141.42 volt divided by 150 ohm, and after calculation 0.943 ampere. This is the current flowing through the resistance R5 and R6. So our results are, already we have determined equivalent resistance of the circuit is equal to 93.33 ohm, the equivalent resistance of all these resistances, and main current of the circuit 2.357 ampere. This is the main current of this circuit, and current flowing through the resistance R1, this resistance, that is I is split into two parts, I1 and I2. I1 is equal to 1.57, and current flowing through the resistance R2 and R3, here I2 is equal to 0.78. Here 0.78 plus 1.57, this is equal to 2.357. That is, this 2.357 I current is split into two parts. One part is 1.57 ampere and another part is 0.78. So 1.57 plus 0.78 is equal to main current 2.357 ampere. And current flowing through resistance R4, here R4 is equal to 1.414 ampere, and current flowing through the resistance R5 and R6 is I4 is equal to, here I4 current is 0.943. Here I3 current and I4 current will meet at point C and again will produce I current. So 1.414 plus 0.943 will be main current 2.357 ampere. So this plus this is equal to 2.357 ampere. So this is the solution of this problem.